we can go ahead and get started. So welcome to another Dynamo office hours community conversation. I'm pretty sure a lot of you probably know the drill at this point, but Jacob and Saul will be hosting and we'll be walking through our Dynamo session today. My name is Tiana. I am going to be your community host for the day. We can hop over to the next slide. So just a welcome again to the Autodesk Community Conversations. Community Conversations, if some of you are new, basically it is a live session where we have expert speakers from the community as well as Autodesk themselves come and basically host an event where we get to learn some of their knowledge and get to make some connections and things like that with them. This is quickly our safe harbor statement. Basically, all this is saying is that please do not make any future looking purchases or decisions on the product based on what we talk about today. And I'll give you guys a second to just kind of look this over. But yes. And again, my name is Tiana. I am a community program manager here at Autodesk. I'm based out of Manchester, New Hampshire, and I am here just kind of to facilitate and help out with Jacob and Saul and Anton as needed, and I will pass it over to them.
Hey, I'm Jacob Small. I'm a technical consultant in the Autodesk Consulting Organization, based out of Boston, Mass. For one more week at least, before I'll be transitioning over to Stockholm. I describe myself as a Dynamo forum junkie. Saul.
Hello, everyone. Absolute pleasure to have everyone here today to join us. My name is Saul. I'm a product manager working on Dynamo. Based here in Boston, Massachusetts, but from New Zealand, if you can't tell by the accent originally. Describe myself as a curious human being, and I'm very excited today to have Anton join us. Over to you, Anton.
Yeah, hi. My name is Anton Huizinga. I'm a software developer from the Netherlands. I create plugins for AutoCAD and Civil 3D for civil designers, mainly for the Dutch market. So I'm a typical Dutch broker nerd.
Awesome.
Awesome. All right, so on to the session. So thank you for joining us, everyone, in the Dynamo office hours. This is session number 45, and this is called Where in the World is My Dynamo, otherwise known as GIS in Civil 3D using Dynamo. So like a typical session, our agenda is roughly a 20-minute presentation that we'll have Jacob predominantly talking through because I'm not such a Civil 3D expert. We'll then have a live demonstration, and both the live demonstration and a lot of the presentation has been given to us by Anton. So very much value your expertise, Anton. Thanks for being with us. And we have a Q&A section at the end as well. But like Tiana said, please do interrupt us at any point in time. We'd love to have a conversation. We want to talk rather than talk at people. So this presentation, we would encourage you to engage with us either via the chat or coming off chat to talk. Jacob,
all right.
over to you.
So without further ado, let's get started. So right off the bat, we're going to get going with coordinate systems because really, if you don't know kind of where in the world your project is, you're going to have a really hard time getting things built. So a few things to kind of go over with the basics. First one is GIS. That's sort of the location data stored relative to your global information system coordinates. You're thinking latitude and longitude as your typical measurements. You're not measuring in feet or meters or anything else like that. Where on the globe does this point rest? After that, we've got Civil 3D as the next part of this sort of tech stack. Our location data is going to be stored by a coordinate system in the file because it's based on AutoCAD, and that's how AutoCAD does its work. It does utilize linear units for its distances, so you don't have to worry about latitude and longitude controlling its points. It's going to give you XYZ variables in something that is a consistent dimension. What I mean by consistent dimension, you can see up at the top there, the space between your longitude actually winds up getting much tighter as you get further north or further south from the equator. Whereas with Civil 3D, dimensions are consistent and much easier to sort of work with. So by setting the coordinate system in Civil 3D, your GIS data can very accurately be sort of linked in, imported, and worked with. Your latitude and longitude for your various parts and pieces can all be reported, and it all happens under the hood without any kind of issues. Dynamo's coordinate system is similar to the Civil 3D one, not the GIS one. But it doesn't have a native means of reporting latitude and longitude. So if you want to do that, you typically have to bounce it out or do a whole bunch of additional sort of coding on top of the tool set. And we'll get into a little bit more about that as we get a little bit further on. And Anton, at any point, if you have any color commentary to add, feel free to speak up. All right, so once we've got that out of the way, let's talk about our coordinates, or sorry, how to set our coordinate systems. This is a node from Arkance, which is Anton's package. Actually, no, this is from Civil 3D Toolkit, I think. Yeah? Yeah, okay.
Yes, that's correct.
Thank you. So you can grab this one and basically use that to sort of set what the coordinate system is based on the coordinates system codes within your Civil 3D documents, which is pretty handy.
If you're reviewing these shops now, that's perfect for them.
And then, what was that?
What shops do you review?
I think I'm going to go ahead and mute that person. There we go. If you did have a question, feel free to come off mute again. It was just a little hard to hear you with the audio the way it was coming through. All right, so this is Anton did a great sort of series of demos on this workflow. So here he's going to go ahead and sort of pull out the correct nodes to start to set those coordinate systems. So he's going to use the current document. Nice use of the node autocomplete right there. Made me smile when I saw that. Wired it in, and then it's done. So real quick, real simple, 3 nodes, gets it out the door. All right. On to the next bit, reading our KML data. So GIS data comes in all sorts of shapes, sizes, and formats. KML is probably one of the more popular ones out there. There's a whole bunch of different ones that are out there. There's actually 3 different ways, 3 different types of data you can access in the Arkance package. But we're going to be working with KML primarily today. So this is a file format used to display geographic data in an Earth browser such as Google Earth. You can get all sorts of great information on the key markup language, I believe it's called, format from Google itself at developers.google.com/KML/documentation. You can get different KMLs through all sorts of different sources. Google Earth's pretty popular, Google Maps, OpenStreetMap data, I think you can get it out of there, as well as other sources, and even make some on your own, which is something that I took a stab at. We'll take look at that later in the session today. Your data will often be much bigger than Dynamo will like, though. So you got to be real sort of careful about not running everything all at once. Don't bring in every tree in the state of New Hampshire in one sort of point file. It's just not going to work. Instead, bring in a plot at a time, or 2 plots at a time, or a segment of a pipe network or something like that, to sort of make it a little bit more reasonable in terms of what that data sort of works with. And this is how we read that KML. Again, this is handy demo of putting together the workflow from Anton. So we put the file insert KML node on there, provide it with the file path. It's going to point at the trees.kml file. And then from there, we can go ahead and start to pull out the individual geometry points. What's great about this is it will serialize out curves, shapes, points, whatever it is that you may need. Dismisses the warning, though you're going to get those warnings pretty consistently in the context of Civil 3D, as we all know, because when we're dealing with GIS data, we're dealing with really big numbers. So expect those to pop up pretty consistently. After that, Anton pulled out the pipe network centerlines. So basically, we're sort of locally orienting ourselves to the stuff that matters in our DWG document, right? We've got all our points that represents our trees. pulled over and in, but now we need the rest of our sort of design content as opposed to our existing conditions. So we're going to use the get the location of all the structures through Camber, and then build a polycurve through the result, right? One quick curve that's going to basically connect all this stuff in a row. Note that if you have a design that can't make a polycurve, such as something that's branching in a Y or branching in a T or something like that, you're going to have to go a different route with this. In those cases, I recommend getting the pipe curves, extruding those curves vertically and joining the surfaces into a single poly surface, because you can manage that pretty quickly and it works fairly well. Here's how that video works. So we go into the Camber nodes, Civil 3D, Civil Objects, Pipe Networks. And then from the pipe network, we can go ahead and get the structures. Takes a document input, and then the name. There's our pipe network. And then from the pipe network, we're going to go ahead and we're going to pull the structures. With that, each of those structure does have location. And then from that series of points that we're going to get from those locations, we're going to go ahead and build one consistent flat list of points, and then a polycurve. Run here. You can see that data very quickly serialized into the Dynamo geometry space. We're not working with AutoCAD objects anymore. We've sort of converted that from the Civil 3D geometry over into the Dynamo side of the equation. From here, we need to build up our buffer zones. There's a few different ways you can do that. We need buffer zones for stuff like, construction, clearances, access, maintenance, security, staging, all of those sorts of things. They are kind of a necessary part of the process anytime you're building a large linear structure. Now, there's many different ways you can find the shape. You can take a curve and offset it in the positive and negative direction. So if I have my original curve like this, we can offset it positive like that or negative like that. And sort of pull that content over from there. The other way that you can pull this off is by doing a thickening curve and normal. So that's basically this version down here, where we provide the curve and the thickness you want to offset it. That's going to build the complete closed polycurve, so you don't have to worry about connecting the endpoints. There's also polycurve offset, which is going to be very similar to curve offset. And then last but not least, the 3D version, which is going to be curve.extrude, and then generate a poly surface from that. Key piece is you want to have a single sort of unified connection here. Quick note for Eric. Eric put in a message asking if we could make Dynamo full screen. These are just video snippets. I'm going to actually go into a full screen Dynamo so that you'll be able to see it. We'll look at the overall workflow, but I wanted to sort of go through the documentation in first before we get to the live stuff. So if it's tight to see, know that we'll get there on the full screen here shortly. All right, so then from here, you can see kind of how we're creating the buffer zones. We've got our polycurve generated from our points. And then we're going to go ahead and pull out from our polycurve, just use the polycurve.offset once for each direction. So we're going to go 25 units and negative 25 units. And then false for, do we want it to extend circular? And see that content generated those two kind of offset polycurves on the Dynamo side of the geometry. From there, we're going to reverse one of the curves so that the start becomes the end. Pull the start points and end points as needed. Each one of those points can then be used to generate a line. our list set up there, and then polycurve by points. Once for each of the sets of points. Go ahead and create a list of our 4 different curves now, one for the 2 cross points and one for the 2 offset curves. And then take the off that sort of list of curves and go ahead and use polycurve by join curves to pull everything in together. And there we have it.
Now, one little fun fact, if you go back for a hot second, Jacob, if you want to, you can use the polycurve by grouped curves, and then it doesn't matter what the order of input is, it's going to automatically join them together.
Great point. All right, so now that we've got our polycurve set up, it's time to look at filtering, right? So we all know that there's no such thing as an impact-free project, right? Anytime you're going to make any kind of an intervention, something is going to have to change. In this case, it's some trees. You know, nobody likes to see trees get cut down, but it's a necessary part of the process here. So a few different ways you can do that. You can do it through polygon containment. You could do it by distance to, geometry intersect also works. I would say distance to is absolutely probably the fastest way to go. There's a few benefits to it as well, which we'll talk about in a little bit further along in the session here. Once you've sort of tested where stuff sits relative to the overall piece, we can sort of separate the points with our standard filter by bool mask. So the process looks something like this. Go ahead and we take our point geometry from way back in the beginning. And get the distance from that point to our original base polycurve. And there, put a less than node and take that distance and say, is that distance less than our minimum offset, which was 25 units? That's going to give us a true or false value for each one of those different points on the screen. All right, so with that true and false value, I think the video, yeah, the video cut out. Okay, sorry guys, having some video issues. We can then take those pieces and filter them out. So one goes one side, the other goes the other. And that sort of sets us up to start to make COGO points. COGO point stands for coordinate geometry, which is a little known fact. Basically, it allows us to associate information with a geometric point, right? One of the great things about this is it's really useful for how we display that data, right? Because those points can represent different things in our space, such as trees or particular points of alignment or feature line or property line or whatever else you may need. And these are also part of the standard library inside Dynamo, so you don't need any extra tools to sort of get at them, which is pretty cool. Quick question in the chat from Fazal, who's a Revit and Dynamo user, has not really been able to get into Civil 3D too much so far. But the sort of terms and workflows are very similar to Rhino and Grasshopper in terms of building geometry. That is correct. That's also correct in the Dynamo aspect and the Dynamo for Revit. Curve pointed parameter, curve.offset, all of these nodes, you can do very similar workflows on the Revit side of things. And the more you interact with your colleagues on those other areas, the more you'll see that we can leverage these same workflows in the civil side, at least conceptually, the same workflows also on the Revit side, which is super useful. All right, so let's talk about how we're creating our COGO point groups. Here we go. So with our different points sort of sorted out, oh yeah, here's where we added the filter by bool mask. I got ahead of myself on the last slide. We go ahead and we wire in the mask, our original list of points all the way back here. Of course, every time I click to let somebody in the room, I wind up pausing the video. Sorry about that. From there, we can go ahead and take our Kogo point group and create one from our points with a group name. This is out of Arkance Systems. Trees to cut as our first tag, and trees to remain as our second. And we're going to leave the group name and the layer as the same value for both of those. Hit run. And you can see it created Kogo points down in our Civil 3D instance. We can then right click those, select similar, and instantly apply our desired method. So in that case, we're applying our cut. On the next one, go ahead and select similar. And again, it's real simple to sort of do that. You don't necessarily need to automate everything. Take advantage of kind of those data sets and sort of capabilities that are already in the tool for your standard automations. Not everything has to be run through Dynamo. All right, from there, now that we've got our Kogo points made, it's time to start to prepare some table data. So this is a whole set of nodes that I didn't know was in there, and I wish I had known that this was in your package, Anton. It would have saved me a lot of headaches about a week and a half ago. But you know, live and learn. So effectively, now that we've decided what trees we want to cut and what trees we want to keep, we can go ahead and we can start to document this data. So we're going to go ahead and prepare a table. This does require gathering the data first. So you decide what's necessary, and all that data has to be sort of prepared in a string format. So from each one of those Kogo points, we're going to go ahead and pull out some of the information. There it goes. Sorry about that. Sol, can you let Sandeep in? Thanks.
Yep, I was going to tell you, don't worry about that. I've got it covered.
Thanks, man. All right, so from each one of the Kogo point groups, we're going to pull out the Kogo points, get the Kogo point number, Kogo point location, for anything that we want to sort of parse out. From there, we can pull the X and Y values. Create strings from our different values. So this is a great node, the get double slash string node, because it's going to sort of get the right number of decimals consistently, which is great. All of those can then be combined into a list create node. This one and index 2. Transpose that list so that the first item in the first list becomes the first item in the second. First item in the second list becomes the second item in the first list, so on and so forth.
You can think of that conceptually as like an Excel document where you've got like rows, columns, and you're just flipping them. Rows become columns and columns become rows.
Exactly, twist it 90 degrees. All right, so from there, now that we've got our data, we can start to create our table. Note that the data is not directly tied to the objects. Again, this is this massive list of tools I wish I'd known about. Next time I think we'll have to inverse the order here just to make my life easier, but there you have it. We can start to create our table object, gather whatever data we might need, create tables, create rows, create table columns, all as your standard AutoCAD content. Which is pretty cool. So the way that works, it's in the Arkance AutoCAD annotation table. And then we can create a table row from a list of values. And then a table column So we've got 3 sets of data that we need. So we go ahead and type those in. There's probably some trial and error, I'd imagine, Anton, on getting those dimensions right. I don't know if you have a rhyme or reason in terms of how you decided 15 and 20.
Yeah, I tried a couple of distances, and this was the best for this table.
Cool. Yeah, one of the nice things about automations like this, it's really easy to edit, right? So if it doesn't work the first time, you can just change that number and hit run again, which is pretty cool. All right, so from here, we go ahead and use the create table. It does need a point, so we use the pick point node. Put that off to the side over there. That becomes our insert point. Location goes in, rows go in, and then the last bit of information is the title. And you can see our table has been created. All right, one more sort of step here to complete the documentation phase, and that is to sort of set up our property sets. So this allows us to basically layer additional data onto our objects in our DWGs. It can be expanded as needed. You can add new property sets and everything else, but it does have to be pre-configured and in the drawing before you can really start to make use of it. Like tables, we do have to prep all of our data first. So Anton put a quick video together on that. So he's going to go into the Civil 3D toolkit. Property set extensions, property set definition by parameter and name. Quickly fills out the names. Description blank, apply to the list, and then yes, apply to all. Set up the data type. Set the name for the property that we're going to put on the definition. You can see we've got our trees to cut set up there with the data that was sort of provided in. Now that we've got our property set, we can start to attach it to our trees. Basically just set the value of the property set once it's all been sort of collected and set up. The associated data in the property set can be pulled out at a later time, used for all sorts of useful documentation and organization techniques, which is pretty cool. So now with our property set, we're going to go into our civil object, Kogo point group, get our Kogo points out of a Kogo point group, and we've got our Kogo point groups up here. So we're going to have 2 sets. Then back into standard AutoCAD because this part is not part of Civil 3D. We're going to go ahead and add the property set onto the objects. Once for each of the lists. And then in Civil 3D Toolkit, AutoCAD menu, property set extensions, set property value by name. One last set of connections in the workflow here. And then we need to say, yes, these are going to get cut. True, false for the other set. Connect those in. And we've watched the whole graph get built. So there's a question from David. Will the property set node work in AutoCAD Architecture 2? I believe so. I haven't tried it. So if you associated the property set in using Dynamo for Civil and then opened it in AutoCAD Architecture, because Civil 3D is built on top of AutoCAD Architecture, believe it or not, the database that you're loading in should work in the file after the fact. So my guess is yes, but it's definitely something that you'd want to check out. All right, so we've seen it all. Any questions for Anton before I jump into, or myself before I jump into the live demo? Feel free to shout them out, or I guess I should say as I jump into the live demo. And Anton, if you have anything to add, feel free to speak up now. But you can see I've got that same file that he had open before. I'm going to go ahead and launch Dynamo. And I should have hit that button before the session started because this is nice and speedy.
So conceptually, Jacob, we're going to do it again live now. We're doing something else.
We're going to do it live just because I know those videos, I tried to make them as big as I could and get them to sort of fit. But even fully sort of blown up to fill the slide, they just pixelated for some reason when I did a dry kind of a dry run. So you can see I've got all the same groups that we kind of had before. I've got stuff sort of frozen out so we can sort of talk stuff through, but I think in the interest of time, because I do want to get to the other demo as well, I'm going to probably run a few of these in sequence. So we're going to go ahead and we're going to get from our objects or from our pipe networks, the curve, each of their center lines by getting all the pipe network by name, getting the structures on that pipe, generating the polycurve by those points. I won't bother dismissing those, but we could. And then with those connected points, doing the offset similar to before. From there, I will also go ahead and unfreeze this. We can have a look at that, run once more, and there is our buffer area, right? So really quick, really easy to access. Great workflow. It's one of those things you have to do all the time for this and all sorts of other stuff. So definitely put that one in your back pocket, everybody. Now this is where things start to get really interesting, right? Because we're going to import from that KML file. We do get the geometry scaling area again there. I'm going to dismiss this one because that one was a little bit annoying for me. But you can see we've got our list of points. Tells us what information about that point. So far we've only pulled out the geometry point data, but if we go into the package, you can see we can pull other information out as well. So we could pull out the label. So if you had a whole bunch of different points and you wanted to sort of group them by what type of data it was, maybe you've got, I don't know, fire hydrants, manholes, and trees all in the same KML. Not that you would, but I don't know. I guess it could be a thing, right? You can go ahead and you can group your points by that and then run through this exact same workflow as you would before, or different workflows. So that's a really, really useful sort of piece there. You don't have to sort of do multiple exports that way, which is pretty cool. All right, so then with our points and our polygon, we're going to go ahead and get the distance between those different parts and pieces. Anything that's less than 25 will return our Boolean value of true and false. And then over here, we can run that into a quick, use that as a filter for our filter by bool mask. We've got the ones that are outside of that 25 unit distance and inside of that 25 unit distance. And then because I don't know Civil 3D, but I do know how to use Python to my advantage, I went ahead and I actually wrote some code so I didn't have to go in and hit those other pieces. with Python here. Anton, I'll certainly share this over with you because it might be something that is of some value for you. But effectively, if I can get my Python script open, maybe. Yeah, I'm locked up. That's not great.
So maybe the Camber package also contains nodes for that? I'm not sure.
I looked. It has it for everything except for Cocoa Points.
Okay.
And I was like, yes, I'm going to be able to. Oh, no, I'm not. Shoot. So I went in, this is our standard boilerplate up above. I did had to add the civil application as well as civil application active document. Get from my civil document, I can then get my styles. From our styles, I can get the point styles. I take the point groups from Dynamo, go ahead and get the internal database object, right? Unwrap it from the Dynamo version of the point Cogo point to the Civil 3D Cogo point. And then I can get the IDs from all of those Cogo points. All right, and then down here, start a transaction, get the style IDs, filter out any style that doesn't match my provided style name. So I only have one style when I'm left, and I pull it out of the list. And then for every point ID in the list of Cogo point IDs, I go ahead and set the point ID, open the point ID, and then set the style ID to the style ID that I found before, and then just return our Dynamo points, right? So in, out, pretty quick, and it looks pretty good when it's done. I didn't have to do any actions there, which was really key for me because I struggle mightily in picks and clicks in Civil 3D. Down here, I then took those same Cogo points as I had, or point groups as I had before, take the individual Cogo points, add the property sets, set that data out, and then one more piece to generate the table, which is the part that I've probably enjoyed more than I should have based on how much of a nerd I am. But yeah, there it is, table created. Off to this side, there we go. All the contents there, editable as I would expect any other point piece to be. Now there was a question in the chat, are the units equal to 1 foot in this example? They're actually equal to 1 meter, if I'm not mistaken.
That's correct.
Yeah, so 1 meter. Yeah, it doesn't really matter as long as your coordinate system that you set in the beginning matches the units in your drawing, you should be good to go. All right, so that exercise is done and I have 20 minutes left. So any questions while I open up the next demo, knowing that my Civil 3D is really slow and it's going to take me a minute to do so. Anything, anybody, Anton, you'd like to add, or Sol?
I would add, if you have these kind of repeatable processes, then Dynamo is a very good tool to use to solve them. So if you're doing these kind of pipe networks and you always need to have a buffer zone, then please build a script like this and use it. It's going to save you time and energy. Yeah.
Great point. In this case, the second demo, I really liked Anton's workflow, and I said, I want to take it to another level. So I want to see what else I can do with it. But I'm tired of pipes. I didn't want to deal with any more pipes. GIS data, absolutely, just no more pipes. So I decided I was going to design a ski resort. Now, disclaimer, I've never even been skiing. I've seen a ski resort once. I've like gone there, but there was no snow on the mountain at that time. So I'm totally wrong in this design. But I wasn't so much designing the actual ski resort as I was designing just something cool. So in terms of the tech anyways. So what I did was I took my actual topography and said, hey, that's what it looks like. We've got some mountain, maybe they're hill, I don't know. It seems like it might be a little bit not slopey enough, but there you have it. This is set to meters as well. And then with that topography, which was randomly generated, I went ahead and I said, I might have a nice, like, happy little loop down that hill like that, and then another one down this hill like that, and then another one over here to get down to there, and another one there. And then when I get to the bottom of the hill, I think I need to be able to do one of those chairlift thingies to get people back up, right? So I need another linear corridor for that. So I made a linear corridor for my chairlift back up as just a polyline again. One over here to get to the top of that mountain, one to connect the sort of lower sloped pieces there, and then one to get the top of that mountain as well. And so with my 10 minutes, we're going to try and build this out live. So I've got the location of my KML file. We're going to start with that. In our Cadence system, we're going to go into import from file. I'm going to import my KML. Run that. You can see I got all my points. From there, we're going to go into our geo points and pull out our individual points. There's all my trees. All right, from there, I need to get into my objects on layer. On layer. Layer.
So search is actually being actively worked on right now to improve, and it is much, 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 much better. This is probably coming out in the 219 timeline, Dynamo 219.
All right, so Anton liked to do the double click to sort of use autocomplete to get to the current document and model space and stuff like that. I like to use code blocks. AUTODESK, sorry, let's do it this way. Document current, open that up, and then pull our current document. It's model space. Sorry. There we go. All right, so now we've got some polylines. We're going to take those polylines and we're going to say polyline object.geometry. There we go. So that gets me some polycurves. Let's check the order that I grabbed those in because I wasn't very smart. So we've got the first one, which is this crazy loop up there. Then we've got this one, which is that loop down there. Then that's going to be the straight. So that's a lift. That's a chairlift. That's a chairlift. That's a chairlift. So I need indices 2 through 5. These two need to go to the end of the list. So I'm just going to use a list dot shift indices. Shift all of these lists by -2, not 2. -2, not 2. There we go. And now when I step through this piece, we're starting with our chairlift, continuing chairlift, 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 and then we get into our curved roots. So we're looking pretty good there. We can hide all of this geometry. And I'm real quick just going to go ahead and say a bracket. We're going to get a list of a bracket 0 to 3 and a bracket 4 to 7. So now I have a list of all my chairlifts and a list of all my runs. From here, extrude a direction. The direction on this, z-axis of 1 by default, which is pretty handy because now when I extrude that up, I got a poly surface by each one of those. I can go ahead and create a joined poly surface from those poly surfaces. And now I have one for all of my chairlifts, hide all of this, and one for all of my roots, which is the second piece. This means I've got one set that I can test for the distances that I need clear on my chairlifts, one set that I can test for my other parts and pieces, right? But before I do that, let's go ahead and by thickening curve normal, offset this piece by our distances. All right, so our thickness is going to be a list. I'm going to go 18 and 36 seems like reasonable distances. Again, I may be way off. These are in meters. Polycurve by thickening curve, normal. Oh, that's my poly surface. I need that instead. All the way back here, actually. There we go. Poly line extensions, object by geometry. There they are. That was pretty easy. All right. So now from these pieces, we're going to go ahead and we're going to test some distances. Distance 2 from our point, and I'm going to use some list levels here. I'm going to work at level 1 to our other objects. It's 2,000 at 1,000 trees, 2 distances per tree for my 2 different parts and pieces. And then I'm going to be able to test is n divided by 2, where n are my thicknesses. Is that less than my double? And let's go ahead and set the lacing on this to be the longest. False, false, true, true, false, false. What are these distances? So that should be true, true. Let's go ahead and be explicit about our list levels. False, true, true, false, false, false. I'm happy with those numbers. So now from here, filter by bool mask. Here's our mask. How am I doing for time, Sol?
You have 10 minutes on the nose.
10
Well,
minutes
I
on
guess
the nose.
minus a minute or 2 for our closeout.
All true. We're going to test this at level 2. Because remember, I've got kind of a list of lists, but if any of those are too close, we want to filter them out. Oh, sorry, any true, not all true. Geometry color by geometry color. Palettes. I'm going to put a set of red dots and a set of green dots together, just so we can quickly visualize these. I'm using Monocle to quickly make my lists here, so I don't have to use the list search. What's really cool about this is you can do stuff like this, like take these 2, make that piece, get rid of that. And let's hide all of those points. If it's red, it's too close. If it's green, it's just right. That was pretty simple. Or I don't know, maybe it was really complex and I just made it look simple.
Looks cool though.
It does look cool. I've never
It's like
designed
Christmas.
this. I've never designed a ski resort before, so I'm really excited about this.
Put boards
right.
on your feet and slide down a mountain.
Yes, precisely. From now, we're going to do some Kogo points. So that was Civil 3D. Was that under Toolkit? Can't remember.
Yeah, you have more options. If you use the Arkance Systems node library, it's in the Civil 3D.
Okay, so in here under Civil 3D, geometry. Aha.
Yes.
That's the one I'm looking for. Group name points.
Yes.
Okay, so my group names are going to be trees dot space cut and trees just by itself. And that'll match our layers too, might as well. Actually, I think I want this to be that based on my drawing standards. Let's see. Two Kogo point groups. That one would have to be cut. Let's check that property. There is topo points. Did I grab the wrong point? Let's check that property. Trees cut. We're good. All right. Back to Dynamo. From each one of our Kogo point groups, I can now take my first one and my second one out of our list, play connect the dots. One more run. It's looking pretty good. And with 5 minutes to spare. And my forte is not color. That is absolutely correct. Soul has to proofread every one of my decks just for colors.
But that's fair, because my forte is not Civil 3D. So, you know,
fair.
We all have our experience. We all have our skills.
Yeah. All right. Any questions on anything that we saw today? GIS or Dynamo geometry? Going once, going twice. All right, Sol, over to you.
Alrighty, so thank you all so much for joining us today, and a big shout out and a big thank you to you, Anton, for helping us put this presentation together and make it all that it can be and provide the amazing use case and Dynamo scripts that go with it. So thanks for that. And thanks everyone for joining us, seeing Jacob and Anton walk through that epic results of working with Where in the World is My Dynamo, or GIS data. So we have some more upcoming sessions, and the next session on the 20th of April is with Zachary Jensen, who is author of the Camber package, and this is called Blocking It Out, where we're working with Civil 3D blocks. Now, Jacob won't be here for that one, but I will be, and Zachary will be the resident expert on Civil 3D in that case. After that, we have May the 4th. May the 4th be with you. If you're into Star Wars, Awakening the Dynamo Force with a mystery special guest, we start to talk about transferring data between different programs. And you know, today we had Dynamo working with Civil 3D. In this case, we'll be working with stuff that is not connected yet. So it could be really interesting. And then a little break, so a little spring break. And then Taming the Chaos is when we start to take a really messy graph that is kind of chaotic and tame it and make it look a little better and behave more appropriately for somebody else to come in and use. Many more awesome things to come after that.
Cool. So there were two questions in the chat while we were going over that, in which we can, since we have a few minutes to spare, I'm going to try and answer those real quick. First one, what was in the Python script? It was the same Python script as before, where we got the civil document, got the point groups, got the point numbers in each point group, and then got the actual Kogo points, got the style that had the matching name as the input, and then set the style ID for each one of the points to that piece. So that's there. And then the second one is a much more philosophical question, and I'm actually curious to hear Anton's thoughts on this. And that question is, what is the level of experience of Civil 3D I should have to work with Dynamo? And I will be as blunt as possible. I started with 0 Civil 3D experience. And anytime somebody brings a new object type, I have to first learn how to do that and then apply Dynamo. But I used Dynamo extensively in Sandbox and Revit before I got there. So Anton, what is your, like, what do you think would be best for that?
Well, you're right. If you want to work with Civil 3D objects, you have to know what they do, what they can. But if you have any experience with Dynamo for Revit, then I think it's not that easy, not that complex.
The great thing with Dynamo is it's geared to not require a lot of experience, right? So because it's simplified, it really enabled me to learn Civil 3D really just by automating things. So question from Eric on where to write Python. And this will be the last question so we can get to the wrap up as well. The best resource for that, I would actually say to check out the Dynamo Office Hours series that have been posted up to YouTube. We had 1 or 2, maybe 3 sessions on working with Python and the Civil 3D API, or just regular Python, Python and the Revit API, all up there. So yeah, it's definitely definitely a great resource. There's other good resources too. The forum is a great place to just, first thing I do if I have a question, I search the forum. It's 1,000,000 times better than ChatGPT and 100 times better than Google to just search directly in the forum. Yeah, you get some pretty good answers there. All right. Oh yeah, and Sol has his great repository. That's more on the Revit side of things than the Civil 3D side, but there's that repository is actually great for Revit and base Python.
All right. So I just want to say thank you all for coming, and also thank you to our presenters. That was a wonderful session. And these are just some ways that you can get involved in the community further if it interests you. We have the forums, our group hubs, we have a blog, and if you want to potentially host your own community conversation, there's a link there where you guys can submit any topics or sessions that you guys might be interested in hosting yourselves. And then those also listed on the other side is where you can find us on social media. I think that about wraps us up for the day. So thank you all. We will be posting this recorded video up onto, again, that community conversations site that you had, or that you visited to register for this. And it will also be up on YouTube. So if you guys want to come back and look at anything, that's where you can find this. And yeah, I think that is everything. So thank you all for coming.
Thanks, everyone.
Thanks again, Anton. That was a great demo that you queued me up with. So wouldn't have been able to pull this off without you.
Yeah, thank you.
Bye all.